Taking a look at our success tracker, you'll notice that we've gone through the first section, which involved using the greatest common factor to simplify fractions, and that involved lessons 1 through 6. Now we're going to start the next section, which is using the lowest common multiple to add and subtract fractions. This section starts off with lesson 7, which is the same name lesson and is actually the most important lesson in the book. So let's get started. Lesson 7. This is the apples plus apples lesson, also known as the same name lesson. And as you can see here, this is the most important lesson in the book because it'll help students intuitively understand why you can't add and subtract fractions unless they have the same denominator. You'll notice that the problems are blank because you want students to follow along with you as you take them through the logic. We'll start off with box A, and it's going to start off nice and simple, then get progressively harder. In box A, we'll start with 1 apple plus 1 apple. So students write this down on their sheet as you demonstrate. And a common answer that students will give here is that the answer is 2. And if they say that, it's actually an incomplete answer. The answer is not just 2, it's 2 apples. So we want them to be precise and use the units. Here, apples plus apples give you apples. So they should write that down first. How many apples? We have 2 apples. Let's move on to box B. Here, we have 3 pencils plus 2 pencils. And using the same logic, pencils plus pencils give you pencils. Write that down first. How many pencils? We have 5 pencils. Box C gets a little bit more challenging. Here we have 4 billion, and spell it out, plus 1 billion. Just use the same logic. Billions plus billions give you billions. So let me write down billion. How many billions? We have 5 billion. And that's box C. Here's box D, and this is where it gets a little interesting. Here we have 3 pencils plus 2 cars. Pencils plus cars give you... And when students get here, they should see intuitively that it doesn't make any sense because pencils and cars are not the same thing. We can't add them together. So we're actually going to cross off box D. Moving on to box E. It's going to get a little bit more challenging, but we're going to use the same logic. Here we have 2xy plus 3xy. xy plus xy gives you xy, so write it down. It's just like apples plus apples gives you apples. How many xy do you have? We have 5xy, and we're done with box E. Box F, we have 7x squared plus 2x squared. X squared plus x squared gives you x squared. How many x squared? We have 9x squared. Box G. Here we have 4m squared n plus 2m squared n. Use the same logic as apples plus apples. M squared n plus m squared n gives you m squared n. How many m squared n? We have 6 m squared n. Here is box H. We have 2mn plus 3m squared n. mn plus m squared n, and this doesn't make any sense because mn and m squared n are not the same thing. They're close, but they're not the same. So we can't add these together. Let's go ahead and cross them off. We're ready for box I, and this is where we'll use our fraction circles to help us. Here, I have a third, and they're called thirds because it takes 3 of them to make a whole circle. So in box I, I'll write down 1/3 and spell it out because that's the key. plus 1/3. Now using the same logic, thirds plus thirds give us thirds. Write it down. How many thirds? We have 2/3. And let's use our fraction circles to check that out. Here, if you have 1/3 plus 1/3, together you have 2/3. So I know that makes sense. Let's go on to box J. Here we have 2/5, spell it out, plus 1/5. Fifths plus fifths give us fifths. How many fifths? We have 3/5, and we're done with J. Letter K, 3/100ths. And make sure you write the THS at the end, plus 2/100ths. Using the same logic, hundredths plus hundredths give us hundredths. Write it down. How many hundredths? We have 5/100ths. Next is box L. And here we have 1/2 plus 1/3. Halves plus thirds give us, and when students get here, they should immediately sense that something is wrong, and intuitively they know not to add them together. Because halves and thirds are not the same thing, they don't have the same name, so we can't add them together. Let's go ahead and cross this off. In box M, we're going to make an important transition. And this is where we explain to students that it gets pretty tiring to keep writing third, third, and third all over again. So we have a different way of writing this. Here in box M, instead of spelling out 1/3, we're going to write it like this. 1/3 plus 1/3 equals, and using the same logic, we know that thirds plus thirds give us thirds, so write it down. How many thirds? Here we have 2/3. Going on to box N, instead of spelling out 2/5, write it this way. 2/5 plus 1/5. Fifths plus fifths give us fifths. How many fifths? We have 3/5. Here's box O. Instead of spelling out 3/100ths, we're going to write 3/100ths plus 2/100ths. Hundredths plus hundredths give us hundredths. How many hundredths? We have 5/100ths. Here's box P. We have 1/2 plus 1/3. Halves plus thirds give you, and again, students should immediately sense that something is wrong. They should intuitively know that you can't add halves and thirds together because they don't have the same name. So let's go ahead and cross this problem off. And notice that I didn't have to get into a complex explanation of looking for common denominators because that doesn't make any sense to students yet. Presenting it to them in this way is much more concrete because they can refer back to the simple example of apples plus apples. You can only add fractions together if they have the same name, just like you can only add objects together if they have the same name. Let's move on to the next box. Here's box Q. Let's write down 1 apple plus 1 banana. Apples plus bananas give you, and students know intuitively that this doesn't make any sense, so let's go ahead and cross them off. But what if I asked you to find a way? So let's go ahead and rewrite the problem in the next box. In box R, let's write 1 apple plus 1 banana. The same problem. And again, what if I asked you to find a way? And students come to realize that, oh, okay, apples and bananas are both fruit. So we can actually rewrite this. Let's cross off apple and write fruit. Cross off banana and write fruit. And now, fruit plus fruit give you fruit. How many fruit? We have 2 fruit. So there was a way to make it work. All we had to do was change the names properly, and the problem made sense. Let's go ahead and take a look at the next box for another example. Here we have 2 roses plus 3 daisies. And normally, we can't add these together because roses and daisies are not the same thing. Again though, what if I asked you to find a way? And students realize, oh okay, roses and daisies are both flowers. So let's rename them. 2 flowers plus 3 flowers. Flowers plus flowers give you flowers. How many flowers? We have 5 flowers. Finally, we have box T. And let's write down 1/2 plus 1/3. And as we saw before, this doesn't make sense because halves and thirds are not the same thing. Again though, what if I asked you to find a way? And it turns out there is a way, and it involves using something called the lowest common multiple, which we'll learn about in the next lesson. So on the bottom here, write down next lesson so that we know what to expect next.